remember that if you add or subtract any any value, like these are the values of x, but if you keep on subtracting -1 or +3 to all the values, the variation doesn't change, the standard deviation doesn't change, the variation doesn't change, the standard deviation does. The effect of adding -1 to +2 is to translate the whole set of values which has no effect on the value of the spread. It's like you are doing f x plus a, so you're just spreading, you're just moving the graph, you're not changing the spread. So the spread doesn't, you see, the spread remains the same. If this was the spread, these are the gaps, this will be the gap, uh, but the spread is the same. The values might change, the values might change. This is x plus 3, the values have shifted 3. It will go back if it's -1. If it's, this is the data, it will move around, but the spread won't change. So the standard deviation won't change, the variance won't change. So that is what he's saying in this formula. He says that if this is the standard deviation for the data x, if I subtract from any all the data b, the standard deviation, the spread remains the same. So this is equal to the spread here. So if you from each data, if you subtract any value, but why do we need to subtract? You see, it makes it easier for us. Like here, if you're subtracting 57.5 from the data, then the data becomes like, if this was the original data 57.5, this is the x, like this is x, and this is the frequency. If you subtract 57, m will become like, and divide by 5, the m will become 0 1, so x will become very simple, it will become very small, the numbers will become very small. So now xf will become 410, x square f will become 1354, and the mean and these values which will be calculated using these will can be just multiplied by the constants and whatever you subtracted from to get the answer. But your calculation will become very easy, otherwise your numbers will become very big. 10215, this is xf, this is x square f. So coding helps us to do handle data, it makes it simpler, calculations easier, and it doesn't, you have a shortcut to avoid big numbers, otherwise everything will become big. If you so he that's what he's saying in this formula. He's saying that if I have a variance with x, if I subtract some number, the variance, the standard deviation and the variance doesn't change. If you multiply, if you multiply, you will have to divide to get the same, and if you divide, you will have to multiply. So this helps us in making calculations easier, numbers smaller. So this is the basic concept of these two formulas, that the standard deviation doesn't change if you subtract something. The mean uh, also will have to be just, just have to, that's what he's doing here. See, he is in this data, this is the mean of the modified this thing, but now what he multiplies by 5 because he's dividing by 5, and he adds 57 to get uh, the new mean. So this is how, this is the usefulness of what we are doing.